In Module 3, we are going to discuss a method of integration known as partial fraction. The partial fraction method is specifically suitable for integrating rational functions such as the one that you see in example 12, example 13, example 14, and example 15, where the function to be integrated is made up of the ratio of two polynomials. This is the general expressions of an rational function made up of a denominator functions Pn and Qm, where both Pn and Qm are polynomial of order n and m respectively. If the order in the upstairs function Pn is less than the order of the polynomial in the downstairs, then the function R will be known as proper fractional function. An example of a proper fractional function would be like this. In this example of R1, it is made up of the ratio of a function P2, where P2 is x squared plus 4x plus 1, and it is a polynomial of order 2, whereas downstairs is x cubed minus x squared minus 17x minus 15. This is a polynomial of order 3. So here n is the order of 2, whereas m is the order of 3. So R1 here is an example of proper fractional function. Another example is minus 2x plus 4 divided by x squared plus 1, x squared plus x plus 1. The fractional functions is made up of an polynomial of order 1, whereas downstairs is an polynomial of order 4. Here is another example of proper fractional function. Given a rational functions of the form Pn and Qm, the integrations of the proper rational functions can be obtained by using the method of partial fraction. To proceed with the discussions of how to use this method to integrate proper fractional function, we have to first introduce two terminology, which we call linear factor and irreducible quadratic factor. Linear factor is simply in the form of an variable x minus an constant term a, whereas an irreducible quadratic factor, IQF as a short form, has a form of an quadratic functions, which is like ax squared minus bx plus plus c, where the discriminant d, which is defined as b squared minus 4ac, is less than 0. The first example of the IQF would be, say, x squared plus 2x plus 3. For this quadratic expression, the discriminant b squared minus 4ac takes on the value of 2 squared minus 4 times 1 times 3. The value is less than 0. Therefore, this is an example of an irreducible quadratic factor. Another example is minus 2x squared plus x plus 3. Let us try to see if this quadratic expression is irreducible or not irreducible. The discriminant b squared minus 4ac is plus 1 squared minus 4 times minus 2, 3. The discriminant is larger than 0. This shows that the quadratic function is not irreducible. So, a quadratic expression can be either reducible or irreducible. So, this is not an irreducible quadratic factor. Here is an example of irreducible quadratic factor. You should be able to easily identify whether an expression of quadratic factor is irreducible or not by checking the values of the discriminant. We will proceed to further explain how the partial fraction method works for integrating an rational fraction. the method only works on proper rational fractions. We always assume the rational fraction to be integrated comprised of an upstairs polynomial and a downstairs polynomial. The partial fraction method can only be applied with the condition that the denominator polynomial Qm can be expressed as the product of linear factor or quadratic factor or combinations of them. If the denominator polynomial Qm cannot be expressed as product of linear factor or irreducible quadratic factor or combination of them, then you can't apply the methods of partial fraction to integrate the rational fraction. Here I'm going to give you a few examples of polynomial function that can be expressed as combination of products of linear factor, irreducible quadratic factor, or combination of them. The first example I'm going to show is this polynomial of order 3. You can easily factorize this into the form of 3 linear factor. So this is an example of an polynomial which could be decomposed or reduced into the product of 3 linear distinct factor. This is another example of a polynomial of order 2. The quadratic expression can be expressed as the product of the common linear factor x plus 1. Here f2 is reduced into the product of 2 linear factor which is common. So here we have an repeated linear factor x plus 1 for the function f2. The third example is f3 and polynomial of order 4. These expressions can be reduced to the product of 3 terms. The first term is an irreducible quadratic factor, whereas the second and the third term are a repeated factor of x minus 1. The factor of x minus 1 here is repeated twice. Function 4 is another example of polynomial order 5, and it could be reduced to the product of 3 terms. The first term is an linear factor, and the second and the third terms are irreducible quadratic factor that is repeated twice. Here, the 4 functions f1 until f4 are examples of polynomial that are reduced to the combinations of linear factor or irreducible quadratic factor. But not all functions of polynomial can be reduced into products of linear factor and IQF. For example, here, the function f5 x cubed plus x squared plus 2 cannot be reduced into the form of the product of 3 linear factor. It can also not be able to be expressed as a product of an irreducible quadratic factor times an linear factor. In our method of partial fraction, if the denominator function cannot be expressed into the form like function f1 to f4, in which they can be decomposed into product of linear factor and IQF, then you can't apply the partial fraction method. So up to this point, we are talking about the integration of a rational fraction where it is made up of a polynomial in the numerator Pn and a polynomial in the denominator Qm. Here we require the Qm to be reducible to the product or combinations of product of linear factor and irreducible quadratic factor. If the rational function fulfill this criteria, then we can apply the partial fraction method to integrate out. In order to use the method of partial fraction to integrate a rational function, you have to learn the rules of how to express the rational function into the form of a partial sum. The rule of expressing a rational function into the partial sum is expressed in these slides. However, to explain the method of decomposing a rational function into its partial sum based on the slide shown here is not as simple. It would be much easier to explain the procedure of doing the decompositions by referring to specific examples, which will be discussed in the following videos. As a conclusion to this video, we have explained some basic properties of a rational function. Specifically, we explained that the rational function comprises of an numerator function and an denominator function. To integrate the rational function using the method of partial fractions, it is required that the denominator of the rational function must be decomposed into combinations of linear factors and irreducible quadratic factor. We have also explained the definition of what linear factor and irreducible quadratic factors as well. In the following videos in this module, we will demonstrate to you how to use the partial fractions method to integrate different types of fractional function.